Ninth century CE. Chang'an, the capital of Tang Dynasty China. Taoist alchemists seeking the elixir of immortality mix charcoal, sulfur, and saltpeter in various proportions, heating the combinations over flames. They're searching for substances that might grant eternal life. Instead, one mixture explodes with a flash and roar, singeing beards and destroying equipment. The alchemists record this dangerous combination in their texts, not as a discovery but as a warning. Some have heated together sulfur, realgar, and saltpeter with honey. Smoke and flames result, so that their hands and faces have been burnt, and even the whole house where they were working burned down. They were trying to defeat death. Instead, they invented history's most deadly substance. This accidental discovery would transform warfare, topple empires, enable European global conquest, and fundamentally alter the course of human civilization. This is the story of gunpowder, how Chinese alchemists stumbled upon explosive chemistry, how it evolved from fireworks to weapons, how it spread across continents, and how it changed everything from medieval castles to modern nation-states. It's a story of unintended consequences, technological diffusion, and a discovery that gave humanity unprecedented destructive power. To understand gunpowder's invention, we must understand the world that created it. Tang Dynasty China, 618–907 CE, was the world's most advanced civilization. Chinese science, particularly chemistry, was sophisticated. Alchemists had been experimenting with substances for centuries, seeking medicinal elixirs, trying to transmute base metals into gold, and pursuing immortality, the ultimate alchemical goal. Chinese alchemy differed from European alchemy in important ways. Chinese alchemists were practical experimenters who carefully recorded results. They understood that certain substances, when heated or combined, underwent dramatic transformations. They'd been working with saltpeter, potassium nitrate for centuries, recognizing its unusual properties. Saltpeter occurs naturally in caves, old walls, and decomposing organic matter. Ancient Chinese texts describe harvesting it from cave walls and latrines. Sulfur and charcoal were also well-known substances. Sulfur, with its distinctive smell and bright yellow color, was used in medicine and fumigation. Charcoal was everyday fuel. None of these substances alone was particularly dangerous, but in the right proportions, approximately 75% saltpeter, 15% charcoal, and 10% sulfur, they create a mixture that burns explosively, producing vast quantities of gas almost instantaneously. The earliest clear reference to a gunpowder-like mixture appears in a Taoist text from around 850 CE, warning alchemists about the dangerous combination. This suggests experimentation had been ongoing, with multiple alchemists discovering and rediscovering the explosive potential of these ingredients. The warning indicates that by the mid-9th century, Chinese alchemists knew this mixture was dangerous, but also that it was interesting enough that people kept experimenting despite the risks. Initially, gunpowder was a curiosity and a hazard, not a weapon. Early gunpowder formulations were relatively weak. They burned vigorously but didn't necessarily explode. Alchemists and early experimenters used it for various purposes: medicine, incorrectly believing it had healing properties; pest control, fumigation; and entertainment, creating smoke, flames, and noise for festivals. Fireworks. Gunpowder's first widespread application emerged by the 10th century. The Chinese discovered that gunpowder packed into bamboo tubes would burn with spectacular effects: flames, sparks, and loud bangs. These early firecrackers were used to frighten evil spirits during celebrations, particularly the New Year. Adding metal filings created colored flames: copper for blue, iron for gold. Chinese fireworks became increasingly sophisticated, with multiple stages, timed effects, and brilliant displays. But fireworks were just the beginning. By the late 10th century, military applications were being explored. The key insight was that gunpowder's rapid gas expansion could propel projectiles. If confined in a strong container with one opening, the explosion would force anything in its path out at high speed. This principle would revolutionize warfare. The earliest gunpowder weapons were incendiaries and psychological weapons. Fire arrows, arrows with small gunpowder packets attached, were used by 900–950 CE. When lit and fired from bows, they'd explode or burn on impact, starting fires and terrifying enemies. Fire lances, bamboo or metal tubes packed with gunpowder and attached to spears, were used by the 10th century. When ignited, they'd shoot flames and sparks up to 10 feet, effective for close combat and psychological impact. These early weapons seem primitive, but they represented a revolutionary concept, using chemical energy, not muscle power, to kill. For millennia, human warfare had relied on muscle, drawing bows, thrusting spears, swinging swords. Gunpowder weapons required only lighting a fuse. A weak person with gunpowder could kill a strong person from distance. This leveled the battlefield in unprecedented ways. The Song dynasty, 961–79 CE, saw rapid development of gunpowder weapons. China faced military pressure from northern nomadic peoples, the Khitan Liao dynasty, and later the Jurchen Jin dynasty. Military innovation became survival necessity. Song military treatises describe numerous gunpowder weapons: bombs, rockets, landmines, and proto-cannons. The thunderclap bomb, Pili Huo Qiu, described in 1044 CE in the collection of the most important military techniques, was an iron casing filled with gunpowder. When thrown into enemy ranks and detonated, the metal fragments became deadly shrapnel, the first fragmentation bomb. Song forces used these bombs defensively, throwing them from city walls onto besiegers. Rockets appeared by the 11th century. Fire arrows evolved from gunpowder packets on arrows to self-propelled missiles. A tube filled with gunpowder and sealed at one end with an arrow shaft attached would propel itself when lit. These early rockets were inaccurate but psychologically terrifying. Launching dozens or hundreds simultaneously created spectacular and frightening displays while potentially starting fires in enemy camps. Land mines, buried explosives detonated by pressure or fuses, were used defensively. The ground rat, an underground explosive charge, could be detonated beneath besieging forces, collapsing tunnels or creating craters. These devices required sophisticated fuse technology, which Chinese inventors developed through experimentation. The crucial development was the gun, a metal tube that could withstand gunpowder's explosive force and direct it to propel a projectile. The earliest guns appear in Chinese sources from the late 12th to early 13th centuries. These were simple tubes, closed at one end, that fired arrows, rocks, or metal balls. The projectiles weren't aerodynamic, accuracy was poor, and reload time was slow. But they could penetrate armor that arrows couldn't, and they were louder and more frightening than bows. The Mongols, who conquered much of the known world in the 13th century, encountered gunpowder weapons when attacking China. Initially, Chinese gunpowder weapons helped resist Mongol cavalry. But the Mongols, masters of adapting others' military technology, eventually incorporated gunpowder weapons into their own arsenal. When the Mongols besieged Baghdad in 1258, they reportedly used gunpowder weapons, introducing them to the Islamic world. Gunpowder technology spread along the Silk Road trade routes. By the mid-13th century, Islamic scientists were experimenting with gunpowder. An Arab treatise from around 1280 describes gunpowder formulations. The Mamluks of Egypt used gunpowder weapons against Crusaders and Mongols by the late 13th century. Knowledge traveled through merchants, captured soldiers, and diplomatic exchanges. Europe received gunpowder knowledge probably through multiple routes: Islamic Spain, trade contacts with the Middle East during the Crusades, and possibly Mongol invasions of Eastern Europe. The earliest European mention of gunpowder appears in Roger Bacon's writings around 1267, though he described it cryptically, possibly to prevent misuse. By 1300, gunpowder was known across Europe. Europeans would transform gunpowder weapons. While Chinese and Islamic societies integrated gunpowder into existing military structures without fundamentally changing warfare, Europeans became obsessed with gunpowder weapons, particularly cannons. Why? Several theories exist. Europe's fractured political landscape created intense military competition. European metallurgy was advanced, facilitating cannon production. Medieval castles dominated European warfare, and cannons could destroy them. The earliest European cannons appeared in the early 14th century. A 1326 manuscript shows a vase-shaped cannon firing an arrow. These early cannons were small, dangerous to operators, they sometimes exploded, and not particularly effective. But they improved rapidly. By mid-14th century, European armies routinely used cannons in sieges. Cannons revolutionized siege warfare. Medieval castles with thick stone walls designed to resist battering rams and catapults were vulnerable to cannon fire. Sustained bombardment could breach walls, rendering castles obsolete. The social implications were profound. Castles were symbols and instruments of feudal power, fortified residences from which nobles controlled territories. Cannons undermined this system. Kings with cannons could reduce rebellious nobles' castles. Centralized monarchy strengthened, while feudal lords weakened. The Hundred Years' War, 1337–145, between England and France saw extensive cannon use. The French used cannons effectively in reconquering English-held territories in the 1440s–50s, reducing castles that had resisted siege for decades. The fall of Constantinople in 1453 to Ottoman forces was partly due to massive cannons designed by Hungarian engineer Urban, which pounded the city's ancient walls into rubble. Handheld firearms evolved in parallel with cannons. The earliest hand cannons, simple metal tubes attached to wooden handles, appeared in the 14th century. They were clumsy, required two people to operate, one to hold, one to apply a match to the touch hole, and were less effective than bows. But they improved. The matchlock mechanism, developed in the 15th century, allowed a single person to aim and fire. Pulling a trigger brought a lit match to the gunpowder. This made firearms practical infantry weapons. The arquebus, a matchlock firearm developed in the 15th century, became standard military issue by the 16th century. It was more powerful than a bow, could penetrate armor, and required less training. A peasant could learn to use an arquebus in weeks, while mastering the longbow took years. Firearms democratized warfare, making expensive mounted knights and skilled archers less dominant. The musket, a larger and more powerful firearm, emerged in the 16th century. Spanish tercios, infantry formations combining pikemen and musketeers, dominated European battlefields. The pike protected musketeers from cavalry while they reloaded. This combination of gunpowder weapons and traditional arms defined warfare for 2 centuries. European global expansion was enabled by gunpowder weapons. When Portuguese, Spanish, Dutch, and British explorers-conquerors encountered Americas, Africa, and Asia, their firearms and cannons provided crucial military advantages. Against societies without gunpowder weapons, European conquistadors achieved disproportionate military success. Cortés's conquest of the Aztec Empire and Pizarro's conquest of the Inca Empire were facilitated by firearms and cannons, which terrified indigenous peoples unfamiliar with them. Disease was the primary killer, but gunpowder weapons provided tactical advantages in battle. Gunpowder also revolutionized naval warfare. Cannons mounted on ships transformed naval combat. Medieval naval battles involved boarding and hand-to-hand combat. Cannon-armed ships could sink enemies from distance. The ship of the line, a warship with cannons on multiple decks, became the dominant naval weapon from the 17th–19th centuries. Naval power, crucial for colonial empires, depended on cannon-armed fleets. Britain's Royal Navy, ruling the seas for 2 centuries, owed its dominance to superior gunnery. Gunpowder's social impact extended beyond warfare. It undermined feudalism, strengthened centralized states, and changed military recruitment. Medieval warfare relied on nobles providing armed knights, feudal obligation. Gunpowder warfare required large infantry armies with firearms, necessitating professional standing armies funded by taxation. This strengthened monarchical power at nobles' expense. The military revolution of the 16th–17th centuries, larger armies, permanent forces, sophisticated logistics, was driven partly by gunpowder weapons. Gunpowder also had industrial impacts. Mining used gunpowder for blasting rock, dramatically increasing productivity. Quarries, tunnels, and mines employed gunpowder extensively. This accelerated resource extraction and infrastructure development. Gunpowder was the first industrial explosive, preceding dynamite by centuries. The chemistry of gunpowder was gradually understood. For centuries, gunpowder was made empirically, following recipes without understanding why they worked. By the 17th century, chemists began understanding combustion and chemical reactions. They recognized that saltpeter provided oxygen, supporting rapid burning of charcoal and sulfur. This knowledge led to improved formulations. Corned gunpowder, with granules rather than powder, burned more uniformly, and was less prone to dampness. Gunpowder manufacturing became an important industry. Saltpeter mining and refining, sulfur extraction, and charcoal production employed thousands. Gunpowder mills, facilities grinding and mixing ingredients, were dangerous but profitable. Governments controlled gunpowder production, recognizing its strategic importance. The British Empire maintained gunpowder factories throughout its territories. American revolutionaries' ability to manufacture gunpowder was crucial to independence. They couldn't have sustained the Revolutionary War without domestic production. Gunpowder's limitations became apparent by the 19th century. It produced extensive smoke, obscuring battlefields. It left residue fouling gun barrels, requiring frequent cleaning. It was sensitive to dampness. Chemists sought alternatives. Gun cotton nitrocellulose, invented in 1846, was more powerful but dangerously unstable. Nitroglycerin, discovered in 1847, was even more powerful but so unstable that accidental explosions killed many, including Alfred Nobel's brother. Alfred Nobel's invention of dynamite in 1867, nitroglycerin stabilized with absorbent material, created a safer, more powerful explosive. Smokeless powder, developed in the 1880s, used nitrocellulose-based propellants that burned cleanly without smoke. These innovations gradually replaced gunpowder for most military and industrial applications by the early 20th century. But gunpowder's historical impact was already complete. It had transformed warfare, enabled European colonialism, undermined feudalism, strengthened nation-states, and demonstrated humanity's capacity to harness chemistry for destruction. The world gunpowder created, of firearms, artillery, and explosives, persists today, even though modern explosives have replaced black powder. Gunpowder's invention was accidental. Alchemists seeking immortality found mortality's instrument. Its spread was gradual, taking centuries to reach Europe from China. Its impact was revolutionary, changing not just how wars were fought but who fought them, who held power, and how societies organized. A mixture of three simple substances, discovered by accident and refined through experimentation, became one of history's most consequential technologies. The irony is profound. Chinese alchemists seeking to transcend death created the means to inflict it more efficiently. Their discovery, intended to benefit humanity, instead weaponized warfare, killed millions, and created an arms race persisting into the nuclear age. Gunpowder reminds us that scientific discoveries are morally neutral. Their consequences depend on how humans use them. From Tang Dynasty alchemists' smoking laboratory to medieval siege cannons, to conquistadors' arquebuses to modern firearms, Gunpowder's thousand-year journey transformed human civilization. It ended the age of castles and knights, enabled global empires, and created the modern military-industrial complex. It showed that knowledge, once discovered, spreads inexorably. China's secret became the world's weapon. And it demonstrated that the most transformative technologies often emerge accidentally, from unexpected places, and for purposes their inventors never imagined. When those ninth-century alchemists mixed saltpeter, charcoal, and sulfur, they weren't trying to change the world. They were trying to escape it. Instead, they created a substance that would explode across centuries and continents, shaping warfare, politics, and human destiny in ways they couldn't possibly have foreseen. Gunpowder's invention was perhaps history's most consequential accident, a failed attempt at immortality that instead gave humanity unprecedented power to end life.